Assalamu alaikum. So the lesson today is about matrices. So we are going to learn how to multiply matrices. But before we start the lesson about matrices, we are going to review a very basic concept about matrices, which is the address of each entry in a matrix. So this is what we are going to do first, and after that we are going to talk about multiplication with matrices. But that review is very important because it's the key of the multiplication. So you need to know it very well. So review. So suppose we have a matrix. We pick any matrix. So we have, for example, four entries. So we have four row and let me pick five columns, as you see the idea. I pick a random example. So that are entries. So each entry has an address. Each entry in a matrix has an address, and the address is the intersection of the row and the column is the intersection of row and column. For example, the first one here is the intersection between the first row and the first column, so we will name it 1, 1. For example, that one is the intersection between the second row and fourth column, so we will name it 2, 4. So this one is the intersection between the third row and second column, so we name it by third row and second column, so it's going to be 3, 2, not 2, 3. So 3, third row, second column. For example, that one is the fourth row, third column. So those are the address of each entry. So here example is fourth row, fifth column. So this is what I want you to keep in mind. Each location has an address, and the address is the number of the row in intersection with the number of column. So that will be your address. This and point, so will be the address is the second row, fourth column. So that point here is between the second row, second column. So I will name it 2, 2. So that's the idea. So please keep in mind this concept is very important. So the location of each entry is the intersection between the row and the column. So the second concept, which is involve multiplication. So we are going to learn how to multiply row and column. So now how to multiply a row with a column. So suppose I have a row. So I'm going to pick a random row. So we have A1, A2, A3, okay, a column. So B1, B2, B3. Multiply a row with a column. So this is one row, four column, and this one is four row, one column. So to multiply a row with a column, so what you need to do, you see this row has four columns. That column has four rows. You see we have one row and four columns. You have 4 rows and 1 column. So if the number of columns of the first matrix equal the number of rows of the second matrix, then we can multiply. That's one of the important number of row or the number of column of the first matrix be equal to second of first matrix should be equal to the number of second matrix. If you cannot have that condition, that means you cannot multiply. Is for multiplication what we do? We multiply the first with the first, the second with the second, the third with the third, the fourth with the fourth. So if they're not equal, there will be one missing. So which means we cannot multiply. So now let's see how we multiply. So I have A1, A2, A3. And this concept works for 2 by 2, for 3 by 3, for any type of matrices, of 2 by 3, 4 by 5, any type, as long as the number of column of the first matrix is equal to the number of row of the second matrix. This is the key. The number of column of the first matrix is equal to the number of row of the second matrix. If you don't have that condition, then don't bother yourself doing multiplication. So B, B1, B2, B3. You multiply the corresponding position. Multiply the corresponding position and add them at the end. So you multiply the first with the first, the second with the second, the third with the third, and the fourth with the fourth. If you have 5, the 5 with the 5, and so on. So here we will have A plus, you multiply A1, B1 plus A B plus A3, B3. You multiply the first entry, the corresponding entry, plus the second entry, plus third, plus fourth, and so on. So how you multiply row by column. I hope it's clear. So let me give you an example to see here, then I move on to the multiplication, which I'm going to talk about the general concept. So here, for example, 2 minus 3, 4 times 1, 5, 7, for example. So what do I have here? This is 1 by 3. This is the number of column, number of row. So I can multiply. So I do what? First with the first, second with the second, and the third with the third. 2 times 1 is 2. Let me do multiplication here. Plus minus 3 times 5, 4 times 7. You don't have to do this way. You can do multiplication in your head if you know the multiplication table. So here we will have 2 minus 15 plus 28. So 2 plus 28 is 30. 30 minus 15 is 15, and this will be answer for the multiplication between that row and that column. So suppose I have, for example, 4, 5, 9, and I have 3, 1. So this is 1 by 3 and 2 by 1. You see those two are not the same, they are different, so undefined. So we cannot find the multiplication of those two matrices. So I hope you got the idea here. So now let's move to the main concept. So let's have two matrices. So M, we have N by M, and we have another matrix K by K matrices. So to multiply So the product of M and by M and and BT exist if and only if we have M equal P. If I have those two numbers equal, then are we can find the product. So which means the number of column of the first matrix, number of rows second matrix. So when we have multiplication of two matrices, write down the dimension of the matrix you have under the matrix. So for example, have this matrix. So let me pick an example to show you the idea how you should do it. So if I have 1, 2, minus 1, for example, 1, 2, 5, 3, 2, 1, 0, 0, 1, for example. So this is the dimension of this matrix. We have two row, three column. The dimension of this matrix is three row, three column. Now what I do, I just compare those two numbers. If you see those two numbers are equal, then go for it and do it. If they're not equal, so you just say there is no solution, or you can say undefined it's better. Doesn't mean you cannot get a value, or you cannot get a matrix for that product. Undefined is now if you see so you're gonna find out a product. Now let me show you how to do the so if M equal P, then you will end up having a product matrix. Then you have so now let me move on. So I have M and by M times N M by K. Now I have those two are equal. The number of column of the first matrix equal number of row of the second matrix. Now a matrix will give me another matrix. The product of two matrices will give me a matrix. So I will have this matrix P, which is called product. Now I need to know the dimension before I do the product. That's the third key. Yes, you need to know the dimension before you do the product. You see, if those two are equal, just cancel those two, and the number of row of the first matrix and the number of column of the second matrix are the dimension of the matrix product. So the dimension will be n by k. So the number of row of the first matrix and the number of column of the second matrix are the dimension of the product matrix. So this is the uh, third key we need to have. The first thing, you need to know the dimension of the matrix, the entry of the matrix. The second key, you need to know how to multiply row by column. And the third, you need to know the dimension of the products before you doing it. Before you do the product, know what dimension it will have when you do the product. Now, so we know that the products will be a matrix. That means it has an entry, and the entry they have addresses. So that's what we need to have. The entry they have addresses. So let's suppose that my product matrix and by k will be this type, but I will write it down in a very condensed notation. So Cij, which is the address of the I row, j column, and this ij as I is between n and 1, and j is between k and 1. That means the I is for the row and j for the column. All right. Now, how can I get that value? What I do? You see, this is the address, the I row, j columns means second row, third column, first row, first column, and so on. So what you do the product. How can I get this? Is by taking the product of the ith row from matrix M, the first matrix, from the first matrix. So I mean by M. So you take the product by j column from the second matrix, which is N, from matrix N. So I take the product of the ith row from the first matrix by the jth column from the second matrix. So that's how you do it, and you already know how to multiply a row by column. So let me show you now in terms of numbers, because I know this is this is very abstract, but let me show you numbers. So let me give you an example. So example. So I will multiply this. For example, we have 5, 1, 1, 0. Let me separate them. And we have minus 4, 3, minus 4, 6. Multiply by, for example, minus 2, minus 5, 3, 6, 5, 0, minus 1, minus 5, for example. Now, what type of matrix I have here? That means the dimension of the matrix is 2 by 4. Here we have is 4 by 2. So those two are equal. So what will be my dimension of the product? The number of row of the first matrix and the number of column of the second matrix. That's mean my product will be 2 by 2. Now, how can I multiply? And I want you to have the freedom. So I will go for more example. So I want to do that one first. I want to do that one first. Or I want to do that one first. So any location I want to start with, I can start with it. There's no specific location. Okay, you have to start from left to right or right to left or up or down. No, you can start from any point. And I told you the address will tell you what to do. For example, I want to start from this, from that location. So what is the address of this location? Is second row, second column. So what does mean second row, second column? Multiply the second row from the first matrix with the second column from the second matrix. Multiply the second row from the first matrix by the second column in the second matrix. So I will multiply that row with that row. It will give me that one. So I will do what? Minus 4 times minus 5 is 20. So it's going to be 20 plus I will have 3 times 6 is 18, minus 4 times 0 is 0, and 6 times minus 5 is minus 30. So the answer will be 8. So this will be 8. Now I want to do, for example, this one. So this is first row, first column. That's mean I'm going to go. This tell me what? Go to the first row of the first matrix and multiply with the first column on the second matrix. First row, first column. First row, first column. You see? First row, first column. So here I will have minus 10. So let's do it here. minus 10, plus 3, plus 5, and plus 0. So at the end we have minus 2. So this will be minus 2. Now I want to do that one for example. This is first row, second column. First row, second column. First row, second column. I will take the first row of the first matrix and time it with the second column. So I will have at the end minus 25 plus 6 plus 0 plus 0. So it's going to be minus 19. So this will be minus 19. Now, the last one here is second row, first column. Second row, first column. I will go to the first matrix. I will be the second row of the first matrix, time it with the first column of the second matrix. Second row of the first matrix of the second matrix. So it's going to be 8 plus 9 minus 20 minus 6. So 8, 9 minus 20 minus 6. So it's 17 minus 26, which is minus 9. So this is how we multiply. So let me give you another example. For example, I want to multiply 0 minus 3, 3 minus 6, 6, 1, times minus 4, 5, minus 5, 4, 1, and 6. So this is 3 by 2. This is 3 by 2. You see, even though they are the same dimension, but we cannot multiply them. Why? Because those two are not the same, they are different. You see, it's not because they are the same dimension I can multiply them. No, there's only one rule. The number of column of the first matrix must be equal to the number of rows of the first matrix. That's the rule. It's not about if they are equal or not. We can add if they are equal in dimension. We can subtract if they are equal in dimension, but for multiplication, it's a little bit different. The number of column of the first matrix must be equal to the number of row of the second matrix. So that's the key. So please keep in mind that idea. So let's do another example of multiplication. So suppose I want to multiply 5, 4 minus 6 minus 1. So times, for example, minus 1, 3, 6, 6, 1, 5, for example. Now this is 2 by 2. This is 2 by 3. So the answer will be 2 by 3, which means I will have the location. Now I can start from any location I want. I don't have to stick with a rule like from left or up or down. No, I pick anything I want. I want to start with, for example, that one. This is 2 by 2, which means what? This is 2, 2. This means second row, second column. Second row, second column. So 24 minus 6, which is 18. So this will be 18. Now I'm going to do that one. First row, third column. First row, third column. So we'll have 5 minus 30 minus 25. So here will be 25. I want to do, for example, that one. First row, first column. First row, first column. Minus 5 minus 18. So minus 5 minus 18 is minus 23. So I move to that one. Second row, third column. Second row, third column. So it's going to be 4 minus 5 minus 1. Now I'm going to move to that one. So which is what? First row, second column. First row, second column. So it's going to be 30 minus 36, which is minus 6. Now the last one is second row, first column. Second row, first column. So it's going to be minus 4 minus 3 minus 7. As you see, I'm not like tight with certain order. You just need to know the location of the product that you want to do. Then for the location, it tell you what to do. Just read the location. I want to read this. I want to start with this one. This is, what location is this? This is 2 by 2. That means this is 2, 2. That means the second row, second column. I just look for the second row, second column. This tell me, take the second row and time it by the second column. This one is 2, 3. Take the second row, time it by the third column. This is 2, 1. This is 1, 2. Take first row, time it by the second column. This is 2, 1. Take second row, time it by the first column. It's simple as it is. And I hope that you understand the main idea. And please, if you have any comment that will help, it will help me really improve my way of teaching, please do so. And thank you for watching the video. Assalamu alaikum.